Hello everyone. Welcome to our channel. Today, we're going to learn about functions, a fundamental topic in GCSE Maths. If you've ever wondered how mathematicians turn inputs into outputs, or what those mysterious function machines are, you're in the right place. What is a function? A function is like a mathematical machine. You put a number in, the input, the machine does something to it and out comes a new number, the output. Example: if our function is double the number and add 1. Input: 3. Calculation: 2 times 3 plus 1 is equal to 7. Output: 7. Try another. Input: -4. Calculation: 2 times -4 plus 1 is equal to -7. Output: -7. Function machines explained. Function machines help us visualize what's happening. Imagine a box with arrows. The input goes in one side. Each box inside does a mathematical operation, like times 2 plus 5 divided by 3. The output comes out the other side. Example: suppose our function machine multiplies by 3, then adds 5. Input: 2. Step 1. 2 times 3 is equal to 6. Step 2. 6 plus 5 is equal to 11. Output: 11. Reverse example. If the output is 23, and the machine multiplies by 3 then adds 5. Step 1. Subtract 5. 23 minus 5 is equal to 18. Step 2. Divide by 3. 18 divided by 3 is equal to 6. Input was 6. Function notation. You'll often see functions written as f of x. F of x means the function of x. If f of x equals 2x plus 1, and x equals 4, then f of 4 is equal to 2 times 4 plus 1 is equal to 9. If g of x equals x squared minus 2x plus 1, find g of 3. G of 3 equals 3 squared minus 2 times 3 plus 1 is equal to 9 minus 6 plus 1 is equal to 4. Composite and inverse functions. Composite functions. Applying one function to the result of another, e.g., f of g of x. Example 1. Let f of x equals 2x minus 3 and g of x equals x plus 1. Find f of g of 4. First, g of 4 equals 4 plus 1 is equal to 5. Then, applying the result of g of 4 to f of 5 is equal to 2 times 5 minus 3 is equal to 7. So, f of g of 4 equals 7. Example 2. Let f of x equals x squared and g of x equals x minus 3. Find g of f of 2. First, f of 2 equals 2 squared equals 4. Then, applying the result of f of 2 to g of 4 equals 4 minus 3 is equal to 1. So, g of f of 2 equals 1. Inverse functions. An inverse function reverses the process of the original function. Example 1. If f of x equals 3x plus 4. To find the inverse, replace f of x with y. Y equals 3x plus 4. Swap x and y. X equals 3y plus 4. Rearranged. X minus 4 equals 3y. Y equals x minus 4 divided by 3. So, f inverse of x equals x minus 4 divided by 3. This process reverses the original function, which multiplies the input by 3 and adds 4, by instead subtracting 4 from the input and then dividing by 3. In other words, the inverse undoes each step of the original function in reverse order. Example 2. If g of x equals x plus 8 divided by 3. To find the inverse, replace g of x with y. Y equals x plus 8 divided by 3. Swap x and y. X equals y plus 8 divided by 3. Rearranged. 3x equals y plus 8. 3x minus 8 equals y. So, G inverse of x equals 3x minus 8. Functions with expressions as inputs. Sometimes, instead of just numbers, we use expressions, like x plus 2 or 2y, as inputs for functions. This helps us see how the function works for any value, not just one number. Example 1. Let's use the function f of x equals 2x plus 1. What is f of x plus 2? Step 1. Replace x with x plus 2. F of x plus 2 equals 2 times x plus 2 plus 1. Step 2. Expand. 2x plus 4 plus 1. Step 3. Simplify. 2x plus 5. Example 2. Suppose g of x equals x squared minus 3x. What is g of 2y? Step 1. Replace x with 2y. G of 2y equals 2y squared minus 3, 2y. Step 2. Calculate. 4y squared minus 6y. Example 3. Let h of x equals x minus 4. What is h of a plus b? Step 1. Replace x with a plus b. H of a plus b equals a plus b minus 4. Example 4. Composite. Let f of x equals x plus 1 and g of x equals 2x. What is f of g of x? Step 1. Find g of x, 2x. Step 2. Put g of x into f. F of 2x equals 2x plus 1. So, f of g of x equals 2x plus 1. Let's try g of f of x. Step 1. Work out f of x. F of x equals x plus 1. Step 2. Put f of x into g. G of x plus 1 equals 2 times x plus 1 equals 2x plus 2. So, g of f of x equals 2x plus 2. Example 5. Inverse. If f of x equals 2x plus 5, find the inverse function. What is the input if the output is 2a plus 7? Find the inverse function. 1. Replace f of x with y. Y equals 2x plus 5. 2. Swap x and y. X equals 2y plus 5. 3. Rearrange to make y the subject. X minus 5 equals 2y. X minus 5 divided by 2 equals y. 4. Write the inverse. F inverse of x equals x minus 5 divided by 2. 5. F inverse of 2a plus 7 equals 2a plus 7 minus 5 divided by 2 equals 2a plus 2 divided by 2 equals a plus 1. Real-life applications. Functions aren't just for exams. They're used in science, engineering, and everyday life. Real-life example. Suppose a taxi fare is calculated by fare of x equals 2x plus 3, where x is the number of miles. Find the inverse function. 1. Replace fare of x with y. Y equals 2x plus 3. 2. Swap x and y. X equals 2y plus 3. 3. Rearrange. X minus 3 equals 2y. X minus 3 divided by 2 equals y. 4. Fare inverse of x equals x minus 3 divided by 2. If the fare is £17, how many miles? Fare inverse of 17 equals 17 minus 3 divided by 2 is equal to 14 divided by 2 is equal to 7 miles. And that's it for today's lesson on functions. Remember, functions are everywhere, from maths exams to real-life situations like taxi fares and mobile data. The more you practice, the easier they'll become. Share your thoughts or questions in the comments section. Thanks for watching. Learning Maths the Easy Way. See you in the next video.